Number 3, given the vertices, determine the quadrilateral's most specific qualification. J, K, L, M. So if we have a quadrilateral, it would look something like this. Again, we're just kind of estimating. This is just to show what the name is, so we can kind of see whatever we have, so we don't have to graph it. So we need to find if JK, KL, LM, MJ, if we have any things equal here. Because if we do, then we need to make sure that we have what type of quadrilateral we have. So first thing we have is JK. And before I even write that JK, what we need to do here is, in order to start this, we have to use the distance formula, which is D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So that is our formula for how to get this to work. So J is at 5, -1, and K is at 8, 2. We're going to start using subscripts to keep our order. We have x1, y1, x2, y2, and use the distance formula. D is equal to the square root of 8 minus 5 squared plus 2 plus 1 squared. 8 minus 5 would get you 3 squared, and then 2 plus 1 would get you plus 3 squared, which would get you 9 plus 9, square root 18. Alright, so that's our first thing we're looking at, is we have square root 18 for JK. Now let's do KL. KL. K is at 8, 2, and L is at 11, 10. So we do our subscripts, x1, y1, x2, y2. D is equal to 11 minus 8 squared plus 10 minus 2 squared, which is equal to 3 squared plus 8 squared, which would be equal to the square root of 9 plus 64, so 73. Okay, now we're looking at the length of LM. L is at 11, 10, and then M is at, we're going to have to write that, 8, 7. X1, Y1, X2, Y2. D is equal to 8 minus 11 squared plus 7 minus 10 squared. We'll get this is equal to 8 would be 3 squared, negative, plus 7 would be -3 squared, which would be equal to 18 square root. Now we're looking at, for last part, would be MJ. MJ, we have M is at 8, 7. Then we have J, which is at 5, -1. X1, Y1, X2, Y2. Gotta keep order when doing the distance formula. D is equal to the square root of, what are we at? 5 minus 8 squared plus -1 minus 7 squared. So you get -3 squared plus -8 squared, all square rooted, which is equal to the square root of 9 plus 64, 53. As we can see right here, we have 18, 18, and that's a horrible 53, 53, 53. So we have two unique sides. So for us to figure this out, it cannot be a rhombus or a square, so the only two choices are a parallelogram or a rectangle. Rectangle, the diagonals are what? The diagonals are equal. In a parallelogram, the diagonals are not equal. So, looking at this, our diagonals are going to be JL and MK. So we're going to see what we have based off this information. So let's write this down and then I'll move it up a little. So J is at 5, -1, and L is at 1110. M is at 8, 7, and K is at 8, 2. Okay, I got my point, so I'm going to move it up a little. Alright, let's see if it's going to be a parallelogram or a rectangle. We have x1, y1, x2, y2, x1, y1, x2, y2. Alright, d is equal to the square root of, we have right here, we have x2 is 11 minus 5 squared plus 10 plus 1 squared. 11 minus 5 would give you 6 squared. It would be plus 11 squared, which would get you 121. 121 plus 36, 157. So we get square root 157. Then here we do distance is equal to the square root of 8 minus 8 squared. 8 minus 8 squared plus 2 minus 7 squared, which is equal to 0 squared plus -5 squared, square root 25, which is equal to 5. 11 minus 5, 10 minus 1. Okay, as we can see, these are not equal, so therefore we have ourselves a parallelogram. So the answer for this one is a parallelogram.